Hey guys, let's talk about database. So we're going to compare Excel spreadsheets and database. Then some advantage of database, examples of database, other types of database, and so forth. Okay. So it's really hard to imagine living without database these days, right? We shop, we just move with the transportation, we travel, workplaces. At this moment right now, without database, it's almost impossible, right? So uh, that's the reason we're using database every day in terms of comparing with Excel spreadsheets. Right? Excel is a great tool, right? We're using every day in workplaces, school, and many places, but there's a limitation, right? So that's the reason we have database for different purpose. Okay, Excel is great, keeping up with all those numbers, doing some statistical calculations, and record all those different type of data, but it may be inefficient when it comes to relate, when it comes to compare, when it comes uh, to the collaborate with other types of interface or applications. So that's where database comes in, especially relational database, because there are different type of database out there. But relation database has been many, many years. And lately we have different type of database like without using SQL, which is no SQL. So that's something we can talk about as well. So structure of database, starting from the lowest or smallest unit, that's the each character, right? When it comes to digital data, we talk about bit and bytes, right? So that's the smallest unit. Then you have column goes vertically. That's the fields, or sometimes uh, call it properties, each column, right? Then we have rows going horizontally, also called records. Then we have fields and records consisting a file. Okay. Well, basically the table consists of columns and rows, and multiple files, multiple tables will make a file, right? And you can have many, many tables in a single file, for example. So basically, if you look at relational database like MySQL or even Microsoft Access, uh, what you see is the table, just like Excel spreadsheets, right? Two-dimensional. You have column, row, and a single cell contain only one type of record. You cannot have two records into a single cell, for example. So that's the kind of main structure of database, a relational database. And when it comes to the database, there are many things we need to recognize because you need to record those records, right? To record all sort of data, you need to have a key, more like index, right? So that you can retrieve those data by a particular key, particular column. So that's what we call keys. So different type of keys, a primary key, foreign key. Um, there's other types of keys in database, but those are two main keys that we need to understand: primary key and a foreign key. So this figure shows examples of a relationship as well as a primary key and foreign key. We have three tables. Hopefully this is big enough so that you can see it. We have email table, student table, and office visit table. Basically trying to show how those tables are related. The main table is a student table. If you look at student table, we have student number with a primary key, meaning as a key identify a unique key identify a record. So anyway, the student number is also located in email table. If you look at it, right, student number is located in email table, so that student number in email table can link email table and student table. Okay, so that's why we call foreign key, a foreign key. Okay. At the same time, student number is located in office visit table, right? Office visit table, we have student number in fourth column. So that's coming from student table as well. So that's a foreign key so that you can link student table and office visit table. So again, primary key and foreign key, right? So that's the main mechanism to link tables in relational database. Okay, so that's one of the most important feature. So that's the kind of things this relation database keep track of things and make all. Even though you have like 100 tables, you can link many of those tables back and forth. All right. So a single database, we consist of multiple database as well as a other admin type of user interface built-in. That's a DBMS, database management system. And on top of that, if you have other applications are attached or integrated, that's what we call database application systems, so that you can talk to the front end, what we call, web server and web interface. So of course, advantage that we already talked about advantages, improved data sharing, security can be improved. It's not perfect, even though data integration, as you can see, you can separate your data into the same kinds of records. So you don't have to mix up different data, just like Excel spreadsheets. Minimize data inconsistency and improve data access. Decision making can be improved as well, so that end user experience can be improved. Again, database management system consists of data, and then you can process data base in terms of read, manage by modifying, deleting, and SQL is a very important tool there, so that SQL basically can make input and also manipulate those records from database. I think this is quite interesting list of tasks that database administration can do. So I think we can kind of glance at. We don't have to really memorize or anything. So development stage, then we have operation stage in database management system, then we have backup and recovery are very important these days when it comes to the security. Then adaptation, so that we can do the testing and we can make some different adjustments. So database application systems, I think it jumps to the database application systems. Okay. Again, database systems consist of database and database management system, which is admin feature, as well as applications that can talk to the front end, like web server or web pages Or for example, if it's in Amazon, you talk to your e-commerce system so that you can record, you can make changes, or you can place your order, then you can shipping to the customers, and you can also link to your banking system, for example, right? So this is a example of that app, database application systems. Uh, so specifically, application running on web server. So in the middle, we have a web server that link backend, which is database. As you can see, database management system on the right side, and left side, that's the front end, so that users are actually using it in terms of website or web-based application, or could be just mobile-based these days, right? So in terms of those apps, think typically just Java-based or JavaScripts using a lot in website, and probably heard about Python, PHP, those kind of apps are running between database management system and the web fronts. So they do a lot of things like connecting each other, as well as providing different functions like users can log in, or security features, and also other important features for the e-commerce site, so that you can make all those updates to their e-commerce uh, programs. I think it's somewhat repeated in this slide. Database design, okay. Well, database design is more like a software engineering, okay. Software engineering is more of uh, following step by step, okay. So you need to have a requirement, user requirement, what they call, right? And you need to understand what users really need, so that you can figure it out what features you need to create. So that's the first step. Then once you figure it out, the output or features for your users, then you come up with some sort of logical design, what they call. Okay, logical design is not using SQL or any types of application yet. You create your table or relationship kind of logically, right, without using application yet. So designers use a lot of diagrams. They use kind of conceptual based app, so that they have clear idea what they're going to create. People putting into actual applications. So ER diagram based is a very good example. So you need to show your design into visual or more of diagram, so that anybody can understand, right? You don't want to write it like an essay, or you don't write it like spreadsheets yet. You don't want to put it. You want to put it into diagram or figures, so that you have clear idea. For example, between tables, or between or any types of entities that you may have. Okay. Then you're going into, with a clear idea of those ER diagram, you're putting into to the application. It's like a MySQL or other types of database application out there. Then you plug in those actual records with properties, entities. Then you create a relationship between physically. Then you come up with your database design. Database output. So that's kind of overview. But when it comes to the actual design, again, ER diagram, right? That's the tool to construct data model. And entities is more like tables, right? Entity consists of different types of attribute consist of columns and rows, and relationships are basically linking multiple tables. So this is a good example of ER diagram. First one at the top is chain model. So multiple types of model can be used, but those are two models are most popular models that people use in database. So one with a chain, you use a rectangle, you use a diamond in the middle so that you can put kind of a verb to describe between two entities, right? Employee, has, dependent, right? So that's how you describe. So use a different type of symbols to indicate that. So also you see the one to the left and M to the right. That's indicate one to many relationship. Okay, meaning that an employee can have many dependent. Same thing, you need to interpret the other way around. A dependent can have only one employee, right? Meaning, whoever his parent or his guardian, for example. And it is exactly the same database, but you use a different model, which is this time crow's foot. That's the name of model. Then, as you can see, there's slightly different symbols they use. So they put all those columns into the lower box, right? So you know what columns you're going to have. But chance, sometimes you don't show all those columns, but this crow's foot, most likely you're going to show all individual columns, as well as the primary keys indicated. And you are using those symbols on the right side. If you look at with those like a foot, some animal's foot with the three things going into. So that's why they call it crow's foot model, meaning that's the many side of the relationship. The left side, you have you have two bars on the left side indicating one each side. That's minimum and maximum. That's the minimum instance you may have, maximum instance you may have for that. Dependent side, you can have many zero or many dependencies. So you could have a zero dependent, you could have 2 or 3, 4, 5. So anytime more than one is many. So that's what you're going to have. All right, so let's move on to, so that's the ER diagram we just showed you before. And then I think I keep showing more. We can spend, long hours on this. I think I want to make it, I don't want to make it too long. So relationship, I think they try to show, what is it? This one, two, okay, different types of, yeah, so trying to show different cases of relationship, even though you have exactly same entities, same tables, but sometimes depending on how you're going to define your relationship, your interpretation can be different. Okay, for example, a department can have multiple advisors. That's the top one, version 2, right? So that's how we're going to interpret a department can have many advisors, and advisor can have many students, but that's many-to-many relationship, meaning that advisor can have many students at the same time as students can have many advisors. So that's depending on how you're going to, assume your database. Other times you can assume or you can have your scenario. An advisor can have only, student can have only one advisor. If you look at the bottom one. So that's why we have. So between department and advisor, many to many, meaning that a department can have many advisors, and same advisor can advise in different departments. That's why there's many to many. At the same time, an advisor can have many students, but a particular student can have only one advisor. That's why you see one to many relationship between advisor and student in the bottom, version. So, so depending on how you're gonna uh, assume your database interpretation or execution can be different. Cardinality. So that's something I just mentioned. Maximum instance, minimum instance. That's the cardinality. So how many cases you're going to have as a minimum and maximum. So that's very important in database, so that whether you understand as a unique or not unique. So depending on what kind of cardinality you have, you need to, design your database, your tables into right place, and you need to link database based on the cardinality. So if you have a many-to-many cardinality or many-to-many relationship, that's really tough in database because you don't know what exactly you are referring to. Because, for example, an advisor, if you can have many students, then you don't know which one because there's a multiple case of students. So that's something this cardinality refers to, whether it is one or many, or could it be zero, right? So depending on types of cardinality, your database design can be really uh, different. In other technique you need to do in relational database, normalization. So normalization occurs when you want to get rid of all those repeated fields, or you want to increase the efficiency of your database by removing all uh, unwanted data, because the main focus of your table is you need to have a minimum number of records. I mean, minimum number of columns. Okay, so that not only you can reduce your file size, at the same time you can increase the efficiency among your database. Okay, so normalization occur. For example, uh, you have two tables. I mean, you have at the bottom you have a single table which is not normalized. Okay, you have that's why we call order table. So we have order ID, product ID, quantity, name, price, those 5 columns, and somewhat this table is not really cohesive, or it's not really unique because you have order ID, product ID are mixed up, right? So these tables supposed to have only order related, unless you have a foreign key or other key that connect to other tables, right? So that's what they have it. And in terms of order ID, product ID, you have order ID looks like it's the primary key, then product ID looks like a foreign key, but it's mixed up, right? So if you have a product table in the first place, and we don't know whether actually there's a product ID, it should have, but it doesn't show it here. So the best way is you can separate this order table into two, so that the kind of confusion can be minimized. Uh, if you look at the first one and third one, product ID is repeated. So that's kind of inefficiency that we're trying to get rid of. So that's why they put it into two different tables. So you have a product table, which is very unique. Individual row has a unique, not only ID and name and all prices. Same thing, order table has a unique ID. However, product ID is foreign key, right? So product ID go back to product table so that you can make a link. You can retrieve the unique ID from product table. Okay, so I think this is good idea, but I think as they just showing this table right away may not be clear for some of us. But that's the idea of normalization. You're trying to convert your table into more structured, more efficient way. Okay, so normalization. Then we talk about relationship. I think we should have talked about relationships in the first place. So what are the idea of relationship? Again, trying to link multiple tables. Two tables. So there's a one-to-one relationship, one-to-many, many-to-many. Okay. Why is it important? So that you can place a link in the right place. Okay. So making link is very important. So if it's one-to-one relationship, it's really not really critical where you're going to put your foreign key. For example, between country and president, right? Because a country can have only one president. A particular president represents only one country. So that's why they call it one-to-one, no exceptions. One-to-many, again, using country as an entity. The other entity is a city. So a country can have many cities. A particular city is located in a particular country. Of course, you can have a same city name, but assuming, the city name is not considered in different countries. Okay. Many-to-many relationship, again, many relationship each other, meaning a country can participate in many Olympic sports. By the way, this is Winter Olympic time. So the same thing, a particular sport like a ski event, you have many countries are participating. So that's why it's many-to-many relationship. So that's how you're going to interpret and execute your relationship into your database. So basically what we talked about was relational database, right? And all those relationships and talk about link, talk about normalization, all that all only apply to relational database. But when it comes to the different type of database, which is in this example without SQL. I think we didn't talk about SQL, but SQL is a query language. It's more like a natural language that execute a particular function in relational database. So many people think SQL is the main, technique you need to understand in relational database. But with the help of AI these days, you don't have to memorize too much. You just probably understand some basic query statement, then AI based can basically taking care of details of query language. But no SQL, coming back to no SQL. So no SQL doesn't require all those structure, tables, link, even query language. So this is a good example of no SQL script. So they put it name, grade, games, and then they put it extra columns so that they don't have to create a tables like at the bottom. So that's the equivalent to the relational database. You have name, grade, games, and you can have multiple other types of columns if you wish. So you don't have to define like relational database. You need to define your columns exactly, whether it is a character, whether it's number, whether it is you have a number as decimal, all those property must be declare, but as you can see, NoSQL doesn't require all those stuff. So very handy and very quick. And that's what we're seeing lately. However, it cannot use in all circumstances, right? And also some of them are very specific to certain applications. That's why it's not, not taking over relational database these days. So still,